Welcome to Navakokon Education Society's Divize College, Chiplun, the online session conducted by Sriram Dandekar. We are studying the derivatives of inverse trigonometric functions. And in that we have studied one problem in the last session. Let us continue with the same problem with different method. The problem was, if y equal to cot inverse of under root 1 plus sin x plus under root 1 minus sin x divided by under root 1 plus sin x minus under root 1 minus sin x, and here x is between 0 to pi by 2, we have to find out the derivative. The answer is, we have 1 plus sin x is equal to cos square x by 2 plus sin square x by 2 plus 2 sin x by 2 cos x by 2, that is cos x by 2 plus sin x by 2 bracket square. Similarly, 1 minus sin x is equal to cos x by 2 minus sin x by 2 bracket square, and therefore square root of 1 plus sin x becomes cos x by 2 plus sin x by 2, and square root of 1 minus sin x becomes cos x by 2 minus sin x by 2, and therefore the original y given to us, it becomes cot inverse of cos x by 2 plus sin x by 2 plus cos x by 2 minus sin x by 2, and in the denominator negative is there. In the numerator, sin x by 2 gets cancelled with sin x by 2, and in the denominator cos x by 2 gets cancelled with cos x by 2. So in the numerator cos x by 2 plus cos x by 2, it is 2 cos x by 2, and denominator is 2 sin x by 2. 2 will get cancelled, cos upon sin is cot. So we have cot inverse of cot x by 2. Cot inverse and cot are inverse functions, so they cancel out each other, and we get y is equal to x by 2. Then its derivative is y is equal to half. dy by dx is equal to half. Let us move to the second problem. It is also similar one. Y is equal to tan inverse cos x upon 1 plus sin x. Now here we cannot apply that thing over here, therefore one simple formula: convert cos to sin and sin to cos. In 10th standard we have studied that cos x is equal to sin pi by 2 minus x, and also sin x is equal to cos pi by 2 minus x. Write it here. Now in the numerator, sin of something, use formula of sin 2 theta. Sin 2 theta is 2 times sin theta cos theta, and denominator is 1 plus cos 2 theta. 1 plus cos 2 theta is 2 cos square theta. Using that formula and cancelling one common factor, that is 1 factor of cos, cancelling 2, we get sin upon cos, that is tan pi by 4 minus x by 2. Tan inverse tan pi by 4 minus x by 2, it remains pi by 4 minus x by 2, and its derivative is y equal to pi by 4 minus x by 2's derivative only minus half. Let us move to third problem. Y is equal to tan inverse sec x plus tan x. It is similar problem to the previous one. Tan inverse, now convert this sec and tan to sin cos. Sec x means 1 by cos x, and tan x means sin x upon cos x. Denominators are same, so it becomes 1 plus sin x upon cos x. Like we did in the previous problem, convert sine to cos and cos to sine? This is because we have to apply the formulae for 1 minus cos theta and sine 2 theta. They are easy to use, therefore I have converted them. Now in the previous problem we used the formula for sin pi by 2 minus theta. Here I am using cos pi by 2 plus x is equal to minus sin x, and sin pi by 2x is equal to cos x. 1 minus cos pi by 2 plus x divided by sin pi by 2x plus x, that gives me the numerator 2 sin square pi by 4 plus x by 2. Again the formula used is 1 minus cos 2 theta and denominator sin 2 theta. Again cancelling one factor, this 2 and sin and 2 cancels, we get sin upon cos, that is tan pi by 4 plus x by 2. So this original y is now pi by 4 plus x by 2 only. No trigonometric term is involved here, and therefore y is equal to pi by 4 plus x by 2. Differentiating with respect to x, derivative of pi by 4 is being constant 0 and derivative of x by 2 is half. This is the answer. Let us move to the fourth problem. It is also almost similar one. Y is equal to tan inverse under root of 1 plus cos x upon 1 minus cos x. 1 plus cos 2 theta formula is 2 cos square theta by theta, and 1 minus cos 2 theta formula is 2 sin square theta. Using that formulae, 2 cancel, square root and square cancel, cos upon sin is cot, tan inverse cot x by 2. Cot can be converted to tan using the regular idea pi by 2 minus theta. Tan of pi by 2 minus theta is cot theta. Now tan inverse tan, they are inverses of each other, therefore nullifying their argument, we get only y equal to pi by 2 minus x by 2 and derivative is minus half as usual. Problem number 5, also similar problem, the same trick that we followed in first problem. Y is equal to tan inverse under root 1 plus sin x upon 1 minus sin x. Now here convert this sin to cos pi by 2 plus x, denominator also. By converting sin to cos and then applying the formula for 1 plus cos 2 theta and 1 minus cos 2 theta, we get this 2 sin square pi by 4 plus x by 2 upon 2 cos square pi by 4 plus x by 2 bracket raised to half, that is square root. Now bracket raised to half and square will get cancelled to each other. You get tan inverse tan pi by 4 plus x by 2. Your answer of y is pi by 4 plus x by 2, and its derivative of pi by 4 is 0 and derivative of x by 2 is half. In this sixth problem, slightly different technique I am going to apply. Y is equal to tan inverse 2x upon 1 minus x square. In this problem, just try to think whether x is equal to sin theta or cos theta or tan theta or sec theta, etc. are applicable. If I put x is equal to sin theta, I get 2 sin theta upon 1 minus sin square theta. Is it a standard formula in trigonometry? If no, then try to use cos theta. 2 cos theta upon 1 minus cos square theta. Standard formula? No. Then see tan theta. 2 tan theta upon 1 minus tan square theta. 2 tan theta upon 1 minus tan square theta. I know that it is equal to tan 2 theta. And therefore I put x is equal to tan theta. and therefore putting x is equal to tan theta, we get theta is equal to tan inverse x. Theta is equal to tan inverse x, and therefore y is equal to tan inverse to tan theta upon 1 minus tan square theta, that is tan inverse tan 2 theta. Tan inverse tan cancels each other and 2 theta remains. Theta means tan inverse x, so y is equal to 2 tan inverse x. 2 is constant, derivative of tan inverse x is 1 upon 1 plus x square, and therefore in this case derivative dy by dx is 2 upon 1 plus x square. Next problem is y equal to cot inverse 1 minus x upon 1 plus x. If I put x is equal to sin theta or cos theta or tan theta, I find x is equal to tan theta is the better option, because cot inverse of 1 minus tan theta upon 1 plus tan theta gives me cot inverse tan of pi by 4 minus theta. This formula is tan pi by 4 minus theta. To solve such problems, I need trigonometry a lot, and therefore the trigonometrical formulae are required in this section. Now converting tan to cot by using the idea tan of theta is cot of pi by 2 minus theta. That again changes the problem y, and I get y equal to pi by 4 plus theta. Pi by 2 minus pi by 4 is pi by 4, minus minus becomes plus. Pi by 4 plus theta, and theta is tan inverse x, therefore y equal to pi by 4 plus tan inverse x. Its derivative is 1 upon 1 plus x square, because derivative of pi by 4 is 0. Now in this problem number 8, 9 and 10, I will show you only the substitution. Cos inverse 1 minus tan square upon 1 plus tan square, it is the formula for cos 2 theta. 2 tan theta upon 1 plus tan square theta is the formula for sin 2 theta. Therefore for both these 8th and 9th problems, x is equal to tan theta is the substitution we are going to use. That gives us y equal to cos inverse 1 minus tan square upon 1 plus tan square, means cos inverse cos, they cancel out, only 2 theta. 2 theta means 2 tan inverse x, and its derivative is 2 upon 1 plus x square. Similarly this 9th problem. 10th problem, sec inverse 1 upon 2x square minus 1. Now here if I put x is equal to cos theta, I have the formula 2 cos square theta minus 1 is equal to cos 2 theta. Therefore I have used this substitution. If I put x is equal to sin theta, then I get 2 sin square theta minus 1. No such formula is there. If I put x is equal to tan theta, then I get 2 tan square theta minus 1. No formula is here, and therefore x is equal to cos theta is the substitution used here. 1 upon cos 2 theta is sec 2 theta. Sec inverse sec cancels each other. 2 theta means 2 cos inverse x, and its answer is minus 2 upon derivative of cos inverse x is minus 1 upon under root 1 minus x square. So the derivative of this sec inverse 1 upon 2x square minus 1 is minus 2 upon under root 1 minus x square. For the next problem, y equal to sec inverse x square plus 1 upon x square minus 1, the substitution used is x is equal to cot theta. By putting x is equal to cot theta, we get sec inverse cot square theta plus 1 upon cot square theta minus 1. Dividing numerator and denominator both by this cot square term, we get sec inverse 1 plus tan square upon 1 minus tan square. This is the formula for sec 2 theta. sec 2 theta, because cos 2 theta is 1 minus tan square upon 1 plus tan square. Sec inverse sec cancelling each other, 2 theta remains, that is 2 cot inverse x, derivative is minus 2 upon 1 plus x square. In this 12th problem, y equal to tan inverse under root 1 plus x square minus 1 upon x. Certainly here I cannot apply x is equal to sin theta or cos theta, because square root will not get cancelled by putting x is equal to sin theta or cos theta, and therefore the substitution is x is equal to tan theta. I have the formula for 1 plus tan square theta is sec square theta. So under root 1 plus x square minus 1 upon x, after this substitution becomes under root 1 plus tan square theta minus 1 upon tan theta. 1 plus tan square theta is sec square theta, square root of sec square theta is sec theta minus 1 upon tan theta. Convert sec and tan to sin and cos and get this answer 1 minus cos theta upon sin theta. Like we solved initially the problems, 1 minus cos 2 theta, the formula is 2 sin square theta by 2, and sin 2 theta, the formula is 2 sin theta by 2 cos theta by 2. 2 get cancelled, one term of sin theta by 2 will get cancelled, and tan inverse tan theta by 2. So only theta by 2 remains. Only theta by 2 means half tan inverse x, and its derivative dy by dx is equal to 1 upon 2 into 1 plus x square. Now in this next problem, 13th, y is equal to tan inverse under root 1 plus x square minus under root 1 minus x square divided by the similar thing. It should be plus somewhere here. It is in the denominator. Plus 1 plus x square. Now here put x square is cos theta. X square is cos theta. Remember. By this substitution I get 1 plus cos theta and 1 minus cos theta. Formulae for them are ready with me. 2 cos square theta by 2 and 2 sin square theta by 2. Cancelling the square roots, we get this one. Cancelling root 2 and dividing numerator denominator both by cos theta by 2, we get 1 minus tan theta by 2 upon 1 plus tan theta by 2. It is tan of pi by 4 minus theta by 2. Tan inverse tan cancelling each other. Only thing remaining is pi by 4 minus theta by 2. Pi by 4 minus theta means cos inverse x square. Cos inverse x square. Now to find its derivative, pi by 4 derivative 0, half as it is, derivative of cos inverse x square, use the chain rule. Using chain rule, derivative is minus 1 upon under root 1 minus x raised to 4 into 2x. That is x upon under root 1 minus x raised to 4. Thank you. This next problem, 14th problem, y equal to sin inverse x under root 1 minus x minus root x under root 1 minus x square. Now in this problem, two substitutions I am going to apply. X is equal to sin theta and root x is equal to sin phi. X is equal to sin theta and root x is equal to sin phi. So the problem becomes sin inverse x is sin theta, 1 minus root x square, that is 1 minus sin square phi. 1 minus sin square phi is cos square phi. Square root of cos square phi is cos phi. Minus root x. Root x means sin phi. And under root 1 minus x square, that is 1 minus cos square, 1 minus sin square theta. It is cos square theta. Square root gives me cos theta only. So sin inverse sin theta cos phi minus cos sin phi cos theta which is the formula for sin theta minus phi. Sin inverse sin gets cancelled and remaining is theta minus phi. Theta is sin inverse x and phi is sin inverse root x. Use derivative chain rule and find out derivative of this. So dy by dx is derivative of sin inverse x, which is 1 upon under root 1 minus x square, and derivative of sin inverse root x is 1 upon under root 1 minus root x square into derivative of root x. It comes out to be 1 upon 2 root x into under root 1 minus x. Next problem is 15th one. Y is equal to tan inverse a cos x minus b sin x upon b cos x plus a sin x. Here put a is equal to r sin theta and b is equal to r cos theta. We get y equal to tan inverse r sin theta cos x minus cos theta sin x, and denominator is cos theta cos x plus sin theta sin x. Numerator is sin theta minus x, denominator is cos theta minus x. It is tan theta minus x. So tan inverse tan cancelling each other, we get theta minus x. But what is theta? A by b is equal to theta. Tan theta. A by b is equal to tan theta. So theta is tan inverse a by b, which is constant. And derivative of constant is 0. Therefore, the derivative of theta is 0. Only thing we have to consider the derivative of minus x. It is minus 1. New problem. Y equal to tan inverse under root 1 plus x square plus x. Put x is equal to cot theta, that gives us tan inverse cosec theta plus cot theta. How cosec theta? Cot theta means 1 plus cot square theta. 1 plus cot square is cosec square, under root cosec square is cosec. Now cosec and cot, convert them to sin and cos. You will get 1 plus cos theta upon sin theta. Use the formula for 1 plus cos 2 theta and sin 2 theta to get 2 cos square theta by 2 and 2 sin theta by 2 cos theta by 2. One term of cos will get cancelled, 2 will get cancelled. Tan inverse cot theta by 2, that is tan inverse tan pi by 2 minus theta by 2. We can convert cot to tan by using pi by 2 minus theta. Tan inverse tan is cancelled, remaining is pi by 2 minus half theta. Theta is nothing but cot inverse x, and putting it here, y is equal to pi by 2 minus half cot inverse x. Taking derivative of pi by 2 is 0 and derivative minus half as it is. Derivative of cot inverse x is minus 1 upon 1 plus x square. So finally the answer is 1 upon 2 into 1 plus x square. Now try to solve all the problems from your textbook and then ask me your doubts on the phone number given in the beginning of this session. Thank you very much.